Okay, so for number 3, we have that the universe is a set of integers, and essentially what we're doing here is we're taking some subsets of it and removing other subsets. So we are given 4 subsets, and that's the even numbers. So the even numbers are, it's going to be this subset right here. We're given the odd numbers, which is going to be this subset right here. We're given z plus, which is this subset, and then z minus, which is that subset. So all I've done here is I've expanded these subsets so that we can visualize them a little bit better. So for item A, we want to begin with the evens, so -4, -2, 0, 2, 4, and we want to remove from it z plus. So if I begin with -4, this continues, right? -4, -2, 0, 2, and so on, and I remove from it the positive ones. Well, it's like I'm removing 2 from it, I'm removing 4, I'm removing 6, and so on and so forth. So it's like all I'm left with are going to be the negative evens and 0, right? So my set here is going to be, it begins 0, and then it goes -2, -4, -6, and so on, because I removed all the positive even numbers. So for B, I'm going to begin with the positive integers, and I'm going to remove from it the evens. So I'd remove 2, I'd remove 4, I'd remove 6, and so on. And so if I remove the evens, you can see that I'm going to be left with 1, 3, 5, 7, and so on and so forth. So my set here for z plus minus e is just going to be the set of positive odd numbers. So that's going to be 1, 3, 5, 7, and so on and so forth. For item C, I'm going to begin with the odds, so -5, -3, 1, 1, 3, and I'm going to remove from it the evens. But if I remove from it the evens, nothing's going to change because there are no evens there to begin with, right? So since nothing changes, the set that I'm going to have anyway is just going to be my odds. So that's just going to be my set of odd numbers. So for D, we're going to have the complement of z plus. So the complement is like every single set that's every single element that's in the universe, and remember that the universe is the integers. So the universe is going to be, it's going to be, say, -4, -3, -2, -1, 0, 1, 2, and 3, and so on. And I want to remove from it the positive numbers. So if I remove the positive numbers, I'm going to remove all of these up until 0. So 0 is not removed because 0 is not positive. So I can see that the set that I'm going to be left with is these are going to be z minus union the set containing 0. So if I remove the positives from the integers, I'm going to be left with the negatives, so z minus union the set containing 0. So that's D. So for E, if I take the positives, right, so if I take 1, 2, 3, 4, 5, 6, and so on, and if I remove from it the negatives, so -1, -2, -3, well, nothing's really going to change because I didn't remove anything because the positives don't contain the negatives. So nothing changed in this case, and all I'm left with is z plus. And then if I have, let's see, E, F. So, if I take the complement of the evens, so I'm going to begin with the real numbers, right? So I'm going to begin with -4, -3, -2, -1, 0, 1, 2, 3, and so on. And if I remove the evens, so I remove this, I remove that, I remove this, I remove that, you can see that I'm just left here with the odds, right? Nothing. I'm just left here with the odds if I remove the evens from it, because all real numbers are either even or odd. So if I remove the even, I'm left with the odds. And so the set is just going to be the set of odd numbers. For G, I'm going to begin with the evens. So I'm going to begin -4, -2, 0, 2, 4, and I'm going to remove from it the negatives. So I remove -4, I remove -2, I remove -6, and all I'm left with is 0, 2, 4, 6, 8, and so on. So let me erase that. So if I begin with the evens and I remove the negatives, I'm going to be left with the set 0, 2, 4, 6, and so on and so forth. So H, I first want to find the intersection of the evens and the negatives, and then I want to take the complement. So the intersection of the evens and the negatives is just going to be I'm going to remove, and the negative, sorry, I have to remove every positive value, but I also have to remove 0 because 0 is not a negative number. So this set here is going to be my, so this set here is going to be my, let me rewrite this, is going to be comprised of -2, -4, -6, -8, and so on and so forth, right? So if I do the complement of it, so I'm going to take every number that's not a negative even number. So if I do the complement, well, first of all, I'm going to have the positive numbers, right? So, because none of these are positive. So my complement is necessarily going to include the positive numbers. Union, it's also going to include 0 because 0 is not there, so it's going to include 0. Union, it's going to include also now the odd, the negative odd numbers, because if I've already taken care of the positives, I've already taken care of 0, and I have also the odd negative numbers which are not here, right? So union, -1, -3, -5, and so on. So that's it for H. And just to repeat this in case it was confusing, essentially I'm going to have my real numbers, which is like -4, -3, -2, -1, -0, 1, 2, and so on. And I'm going to remove the intersection of the evens and the negatives. So I'm going to remove this, I'm going to remove that, and I'm going to remove -6 and leave everything else. And lastly, for I want the complement of the empty set. So the complement of the empty set is everything that is not in the empty set. But there's nothing in the empty set. So actually the complement here is going to be all integers because I've not removed anything from that set. So that is it for number 3.